Hey, everybody. So we are getting into chapter 12 today, 12.1, called Triangle Proportionality. All right, this is starting with the triangle proportionality theorem. So go ahead and take a minute and get the title, get this theorem and everything, and then I'll show you what's going on. All right, so I guess first thing, let's just kind of dive in and look at what the triangle proportionality theorem is. It says if a parallel line to a side of a triangle intersects the other two sides. So let's just kind of break down what that means. Okay, so they're saying that if a line parallel to a side, then we can see that this line right here is parallel to this side length. We can see that because of those arrows. It's saying if it intersects the other two sides, which it's doing, it's crossing them. Okay, here's what it does. Then it divides those sides proportionally. All right, so what it's telling us is that these side lengths are being divided proportionally. And what that means is that the ratio of the two pieces of the sides are equal to the ratio of the two pieces of this sides. Okay, and you can see that in this thing right here. We can see that AE over EB is equal to AF over FC. Okay, and that is the triangle proportionality theorem. All right, here's the good news. It's creating a proportion, and what we were doing in chapter 11 was also very, very dependent on proportions. All right, the only difference between this lesson and what we were learning in chapter 11 is the parts of the proportion are just slightly different. Okay, so it's of the two pieces, the ratio of the two pieces of this side is equal to the ratio of two pieces of this side. Okay, that's basically what this is all about. All right, so as long as we're getting our numbers in the right spots, we're good to go. So let's go ahead and try this out. Okay, so go ahead, copy this example here, and we're going to find CY. Okay, so taking a look at this, CY right here is this side length. Just to kind of make it easy on us, let's call this side length, let's make it a variable. X is being used right here. Normally I would call it X. Okay, as long as you understand that those two X's are two different things, I don't know, maybe we should use a different variable. Let's see, they're already using Y. I don't know, let's just call it CY. Let's just use CY. It doesn't really matter. Okay, so anyway, we're looking for CY. Here's what we know. This parallel line right here that's parallel to this side is cutting these side lengths proportionally. All right, so let's start with the proportion of these two pieces, CY and 10. Okay, there is our first ratio we can make. So CY over 10. By the way, here's a big thing. When you make these ratios, you need to follow the same pattern. Okay, again, I went left over right. When I go to make this other ratio, I need to also do left over right, left piece over right piece. All right, so we got CY, which again, this is just a variable. We could have just put, I just want to point out, we could have just put X in here and solve for X, but I'm using CY because we already have an X on this. Sorry if that makes it confusing. Okay, so yeah, my other ratio, I'm going to do of these pieces a 4 over 9. Okay, and then from here, we're just cross multiplying and solving. All right, I can't make up my mind with this CY thing. Let's erase it, guys. Let's just call it X. Let's put it out of its misery. Okay, so we're calling this X. Let's go ahead and solve here. So yeah, this ratio, I just want to remind you, we could, if possible, we could reduce this and then cross multiply. It's not possible to reduce this one, so let's just go ahead and cross multiply. So we got a 9 times X is going to equal a 4 times 10. So 9 times X is 9X, 4 times 10 is 40. All right, and then from here, dividing 9 into 40, this is where you might want to grab a calculator because, you're going to get a decimal on this. We're going to get X equals a 4.4, and it repeats 4. All right, so just a reminder, 4.4 if it repeated. The question is this is, we round the tenths. Does this stay a 4 or does it round up to a 5? Well, it's all dependent on this number. If this is a 5 or more, this would round up. It's not, so this is going to stay a 4, so 4.4. Okay, and there it is. All right, so when it comes to the math, cross multiplying, nothing's changing from the last chapter. The big thing is just making sure you write your proportions correctly. Make sure you're making them your ratios of the two parts of a side length. All right, that's the only thing that's kind of different. Okay, so let's try another example together. So go ahead and copy this one. It's a little bit different. Okay, so first things first, they're asking us to find Pn. So here's Pn. Let's go ahead and call it x for our variable. Okay, so that's what we're looking for. So let's just start by making our first ratio. Again, we have a parallel line right here, and it's cutting these sides into a ratio that is equal to the ratio of these parts. Okay, so I'm going to do since this is top and bottom, I'm going to do top over bottom. So I'm going to do a 3 over x as my first ratio. Okay, here's what we got to be careful of. If I'm doing 3 over x on this one, what should my ratio be? Should I do a 5 over 7 or a 7 over 5? Okay, well, no, neither one of them. Just to kind of point it out, if I were to highlight it, we did this piece over this piece. When we make our other ratio, we need to do this piece over this piece. But I don't know what this is. At least they don't explicitly show me. But I can use some common sense and realize, okay, if this whole thing is 7, the whole side length is 7, and this is 5, that means this must be 2, right? Okay, so just look out for that. We're not actually using the 7 in our ratios. We were using it to find this, piece of this side length. Okay, so again, top over bottom, 2 over 5. Okay, and that's, the hard part from here, cross multiply. So 2x is going to equal 3 times 5. So 2x equals 15. All right, and then, dividing both sides by 2, taking half of 15, you're going to get 7.5. Right, and there we have it. Okay, so yeah, be careful. Make sure you're making your ratios of the two pieces of the sides when, make sure you're following, I guess, the same pattern on both ratios, I guess is the best way to put it. Okay, so I'm going to have you guys go ahead and try one on your own. On this one, it's asking you to find Rn. So you're finding this piece right here. Okay, go ahead and set up your ratios. Be careful when you make that second one. Okay, give it a try. Okay, so my first ratio, I would start with, the two pieces of this side length. So left over right, I would do a 10 over x. Okay, and that means on this one, I'm also going to use the two pieces of this side. Okay, and here's the problem. I know this piece, but am not given this piece, but I can do some math, right? If the whole thing's 12 and this is 8, I can subtract these and I can get that this must be 4, right? Because 8 plus 4 is 12. All right, so there it is. That was, the only little speed bump. Now we can go ahead and make our ratio left over right, 8 over 4. Okay, from here, I can cross multiply and solve. But again, I want to remind you, I have a ratio here that can be reduced. I'm going to do that real quick because I know I can do this in my head. An 8 over 4 reduces to a 2 over 1. Okay, so I'm doing that. Now I have easier numbers. It looks like I'm getting a 2x equals 10. Divide both sides by 2. Looks like x equals 5. All right, cool. So yeah, that's kind of the idea. You'll see in some of these problems, it's going to throw a little wrinkle here and there. So let's keep moving along here. Okay, the other thing we need to look at is what's called the converse of the triangle proportionality theorem. All right, I'm trying to think if this is worth you writing down. I think it is. So take a minute and go ahead and copy this thing, and we'll understand what this is. Okay, so this is basically saying the reverse of the thing we just learned. Just to kind of remind you, on the triangle proportionality theorem said, if these lines are parallel, then the side lengths are proportional. All right, or it's divided into something that's proportional. This is saying the opposite. It's saying if the side lengths are divided into parts that are proportional, then we can say that the lines are parallel. All right. So if we can figure out if they're actually, divided proportionally, we can say, yep, the line is parallel. All right. That's all this is saying. It's basically just the reverse, the converse of that last theorem. Okay. So let's see a problem that actually is asking us a problem that requires us to think this way. Okay. So on this example, go ahead, get this one, and we'll do this together. Okay. So this is asking us to verify that the line segments are parallel. Okay, so here's the question. Is this line right here parallel to this side length? Okay, that's the question right there. Are they parallel? All right. Well, for us to be able to say yes, we need to show that the side lengths are being divided proportionally. All right. So we need to set up these two ratios. We need to reduce them and see if they actually reduce down to the same number, a lot like what we did in chapter 11. All right. So I'm going to go ahead and start with the two pieces of this side length and make my first ratio at 21 over 42. Okay. And I'm wondering, is that equal to, the ratio of the two parts of the other side length, a 15 over 30? Okay, so now we just need to reduce them and see. I'm taking a look at this and I notice, 21, that goes into 42. So I know that's the biggest number. 21 goes into itself once and 42 twice. All right, and again, I'm wondering, does that equal a 15 over 30? Well, yeah, 15 goes into itself once and 30 twice. Okay, so these are in fact equal, and I always like to put a little check mark next to it. Okay, so since the side lengths are divided proportionally, we can say that yes, the line segments are parallel. Okay, so let's write that whole thing out for our notes. Yes, let's say the lines are parallel. Yep. And a little reminder, the shorthand for parallel is those two vertical lines. I could have written parallel like that. If you ever see that shorthand. Okay, so yeah, nothing too crazy there. Just if they're asking for whether the lines are parallel, you're just gonna set up those ratios, see if they reduce down to the same number. So I'm gonna have you guys try out one of these. Okay, so same directions. You probably don't need those again. Go ahead and copy this new one and let me know if these two lines are parallel. Okay, make your proportions. Try it out. Okay, so making my ratios, I'm going to start with this side and the two pieces of this side length. I'm going to do top over bottom because that's just normally how I work. So 6 over 4, I'm wondering if that's going to be equal to the ratio of the two parts of this side length, and 8 over 5. Okay, so 6 over 4, I'm thinking 2 goes into both of these. 2 goes into 6 3 times and 4 twice. Okay, so the question is does this also reduce down to a 3 over 2? Well, an 8 over 5, I'm thinking there is no number that goes into an 8 that also goes into a 5. Not a number bigger than 1. So this does not reduce. This stays an 8 over 5. Okay, so these are not equal to one another. So are these lines parallel to one another? No. Okay, so always look out. Sometimes, the answer is no. Don't assume that it's going to be yes. Check. That's what it's all about. Okay, so the last one we're going to do together is this problem. We'll do an example. So go ahead, copy this. Basically, we're going to do some 4 problems here and match it with these multiple choice answers. So take a minute and copy this. Okay, so first things first, on number 11, they're asking us for a GF. So GF is this thing right here. So for now, let's just call it X. Okay, and by the way, once I figure it out, I'll probably put the information onto the shapes since we're asked multiple questions dealing with the same picture here. All right, so here's the thing. Right now, there's actually like a bunch of overlapping triangles here. Here's sort of my focus. I have this triangle and I have this triangle. Okay, and really, actually, I don't even need to really focus on this first triangle. Really, my focus is on this big triangle right here. All right, that's all that matters. Okay, and to find this side length, I know that since these are parallel, this line here and its side length, I know that the ratio of these side lengths are going to be equal. They're going to be proportional. Okay, so that, it's just like the previous problems. It just looks a little bit strange. Okay, so here's my first ratio, a 6 over x. Okay, I'm going to do my work up here. Okay, so a 6 over x. I'm going to set that equal to the ratio of the two parts of this side length, a 4 over 6. All right, I could reduce a 4 over 6, but this time I'm going to choose not to. I'm just going to go ahead and cross multiply. So 4 times x is going to equal a 6 times 6. So 4x equals 36. Okay? And then from here, divide both sides by 4. You can use calculator if you need to, and x equals 9. Okay, so there is one of our answers over here. Let's go ahead and show. It looks like 9 is A. So there we go. All right, I'm going to put that information onto my shapes. I'm going to erase all of this now just so things don't get too crazy. But now I know that GF is 9. Maybe this will help me on a problem in the future. Okay, from here, let's take a look at FC. Okay, FC is this entire side length right here. All right, so it's a side length. All right, so I'm going to call this thing X. Okay, so here's kind of the thing to wrap our brains around. We're dealing with a side length, an entire side length that is not being, cut into, it's not being cut into, I guess, equal halves or proportional halves. All right. So really, this problem is asking us to go back to chapter 11. Okay. Here's what we got to notice: this triangle right here and this triangle right here. Okay, they are actually similar triangles. All right, if we actually broke it down, we would have angle similarity on this, just to let you know. Okay, but they are similar, and that means I can make a ratio of their side lengths, their corresponding sides. Okay, so we're actually again reverting back to what we learned in the last section. Okay, so the first ratio I'm going to make is this side length and its corresponding side. So a 5 over x is going to be my first ratio, 5 over x. Okay, and that's going to be equal to the ratio of these side lengths. Here's the thing that's tricky. This side length of this red triangle is a 4, so I'm going to start with that. And this other side length of the other triangle is this entire thing, which is not a 4 and not a 6. It's a 4 plus 6, a 10. All right, so that's the tricky part, is realizing, oh, this entire side length is those two numbers added together, a 10. Okay, so that's the weird part of this problem. Let's go ahead and make our our equation. So a 4x is going to equal a 5 times 10, so 50. Divide both sides by 4. This might require a calculator. 50 divided by 4, I'm getting a 12.5. Okay, so it looks like for number 12, B is our answer. Okay, but make sure you're showing this work right here. Okay, so again, a lot of colors and stuff here. I'm going to erase all of that, and now I know that this right here is 12.5. Maybe that'll help me in the future. Okay, let's keep going down. So ED is the next one they're asking us to do. ED is this side length right here. Okay, so I'm actually going to have you guys try this one on your own. This is just like the last problem. Here's what's going on here. Okay, ED, by the way, let's call this thing we're looking for X. So we're looking for this side length. All right, so we're dealing with this entire triangle, this red one. Okay, and we know that it's similar. We could actually say it's similar to this one right here, or the small one. I'm just going to recommend you using the small one. Okay, so those are my similar triangles. I can now make a proportion with those corresponding sides. Okay, so just to kind of get you started, I can start out by first doing this side length. Let me maybe use blue. This side length and its corresponding side, that can be your first ratio of 5 over x. Okay, so I'm getting you started on this one, 5 over x. Okay, but what am I going to set that equal to? All right, well, it's going to be the ratio of, you can use this side length and this corresponding side of this triangle. Okay, so go ahead and make your ratio out of those parts. All right. Okay, so here's what I'm hoping you did. You notice that this side length of this green triangle is a 4 over the corresponding side of this red triangle, which is this entire thing, 4 plus 6 plus 4, all right, which would give us a 14. All right, that's the weird part about these problems, because these triangles are overlapping one another. All right, so now let's cross multiply and see what we get. So 4x equals a 5 times 14. So we got a 4x equals, let's see, 5 times 14 gives me 70. And then 70 divided by 4 is going to give me a 17.5. Okay, so it looks like number 13 is D. Okay, All right, last thing is on number 14, FE. Here's the thing, FE, if you take a look at this, we already know we have this is A, this is B, this is D. We only have C left over. I can almost guarantee this is going to be C. But let's check. Okay, and actually, I want to show you a kind of a little shortcut we can now use now that we have some information on this. So let me erase all this right here. Okay, so here's what we got. We're looking for FE, this right here. Okay, and if you guys take a look, we have ratios of corresponding sides, or I guess we have the sides that are being divided proportionally. Sorry, I know that's confusing to hear out loud, but basically what I know is that the pieces of this side length, the ratio of these, I can set it to the ratio of these pieces, okay, which is kind of weird. But if you guys notice, both of these pieces are 4. This is a 4, this is a 4, and its corresponding piece over here is a 6. That means this one is also going to be a 6, all right? And that's actually, yeah, our answer. It's going to be 6. Okay, so maybe on this last one, I don't necessarily need to write out a proportion. I could have. There's actually so many ways of finding FE on this problem. I could have made, like I could have done, let's see, like a 15 over x equals a 10 over 4, like just to kind of show you, 15 over x equals 10 over 4. Cross multiply, I would get a 10x equals, sorry, I don't want to mess up here, 15 times 4 is 60. And dividing both sides by 10, I get x equals 6. All right, sorry, you can't really see that. Okay, but I just want to show you a lot of these, when you go to make your proportions, as long as you're using, I guess, corresponding pieces, you're going to come up with the correct answer. And that's kind of the cool thing about these triangles that are overlapping with these parallel lines. Okay, cool. So yeah, that's this lesson today, guys. I'll see you in class. Bye.